In this video, we're going to continue looking at data transformations. We have one more function from the dplyr package to look at, and it is the summarize. So this first part of the notes, this is exactly what you saw in 7.1 and 7.2. So the most important thing here is make sure that you do call forward the tidyverse. All right, we're going to use that same data set we were using before. This is that car seats data set. So if you want to go ahead and run this, and again, same data set that we looked at in 7.1 and 7.2. So just as a little bit of a reminder, if you want to read about that car seat data set, remember this is a simulated data set containing sales of child car seats in 400 different stores, and we've got a couple different variables here from this data set. All right. So now again, we're working with dplyr, 5 different functions we're interested in from dplyr. These first 4 we've already looked at, so that just leaves us the summarize. So it's always a good idea to make sure that you understand missingness in your data set to see if there are any missing values, because remember that we saw in one of the previous labs that when it comes to calculating mean, median, things like that, if we have missing data, that might be a problem. So as a reminder, here's how you can check for missing data for any variable in your data set. Notice that price is one of our variables. So here what I'm doing is I'm calling the car seats data. In particular, I'm pulling out the price variable from that data set. Sorry, if I said car seats variable, car seats data set here. So we got car seats data set, pulling out the price variable. What is.na does is that goes through piece by piece. It gives a true if it's missing, false if it's not, and then if we sum all those up, it will give us the number of missing. So for this particular data set, for price, we don't have any missing data. Now what summarize does is it collapses a data frame into a single row. And so let's look at the output of this first, and then we'll talk about what happens. All right. So notice it gives us a single value here. So what this does is the summarize function, as with all of these functions we've seen, the first argument is the data set. So here we have the car seats data set. Then what it's doing after this is it's defining a new object, price underscore mean, and it's just saying that's equal to the mean of price. So this is just a fancy way to compute the mean of price. And if you'll remember before when we saw how to calculate the mean, we could do this. And we get the same value. So by itself, summarize is not the most terribly useful function because it's just a fancier way to calculate a mean, but it's very useful when we pair it with GroupBy, and that's what we're going to look at next. But before we do that, just as a reminder, up here, the reason that we needed to check for missing values is because when using the mean function, if we have missing values, we need to include that remove in a statement. So just remember that. And you can always include this statement by default. It's not going to hurt anything to include it. But just remember, if it's not in there and you have missing values, you're going to get an error back. So like I just said, summarize by itself isn't terribly useful, but it is if we pair it with what is called GroupBy. So let's look at an example here. So remember in this data set, one of the variables we have is shelf location. And so if we look here, a shelf location is a factor with bad, good, and medium to indicate the quality of the shelving location at the store. So what we can do is we first use this GroupBy function and create a new object that's called by shelf. So if we run this, and then I come up here and I look at by shelf, what is happening is it's going to take the car seats data set and it's going to group it by shelf location. So if we click on the by shelf now, notice if we go over to the shelf location, it has grouped it So if we look here at shelf location, we don't see that grouping, but if we come over here and we look at the by shelf object, notice down here we do have an attribute of groups, which is stored as what's called a tibble. We're going to talk about tibbles more later on. And what it's done is embedded in that object is the 3 different groups. So we're not going to see it here, but you can see it here. Whereas if we click down on car seats, notice that is not included at the bottom of car seats. All right, so again, going back to our script. So if we run this, what it's going to do is the summarize, instead of giving it the name of the data set, we give it this new object by shelf that we created. And notice here, we get for each of the shelf locations, we get the mean price. And we're not restricted to just one grouping variable. For example, we might want to group by shelf location and US. And if you'll remember US, what that did was that gave a factor of levels no and yes to indicate whether the store was in the US or not. So we do something very similar here. Run this, and you'll see now we have 4 of those different combinations. So we have for bad, not in the US, bad, in the US, and then the mean price of those car seats. So looking here at the code, with the first line, we're creating that object by shelf. I've called it by shelf 2 since we already have another one up here. Group by, give it the name of the data set, and then the 2 different variables you want to group by. Notice here I have shelf location first and then US. So down here I have shelf location and then US. If you flip those, it will flip the ordering there. And then the summarize is pretty much the same thing that I had up here, except now I've got the by shelf 2. Alright, so the next thing we need to talk about is what is called the pipe operator. So the pipe operator allows us to combine multiple operations. When you first see the pipe operator, it's a little bit confusing, so we're actually going to spend lab this week looking more at the pipe operator. But suppose we want to explore the relationship between sales and average price for each different types of location. Oh, sorry, not each location, but for advertising. Alright, so the first thing I'm going to do is let's look at that advertising variable. We haven't looked at it yet, so I'm just going to use my table function. So even though advertising is quantitative, I can use the table function on it because advertising doesn't have a ton of different values that it takes. And so remember, advertising is the local advertising budget for a company at each location in thousands of dollars. So for example here, there were 144 that had less than $1,000 in advertising budget. There was 8 that had $1,000 in advertising budget, 9 that had 2, and so on. So the first thing I'm going to do is I'm going to group the car seats by advertising. So if we look across here, making sure, let's see, so I got 26, 27, I've got 28 different levels of advertising here. So I'm going to end up with 28 different groups. So again, if we look at by ad budget here, if we go down and we look at the tibble, we can see that there are 28 different groups that it creates, and it stores the data for those 28 different groups. So the next thing I would need to do is use summarize to compute the number of car seats, average sales, and average price for those groups. So what this line of code is going to do is it uses summarize, and it's going to find 3 different things. It's going to use that by ad budget grouping that we created. This line of code is going to store the number of observations in each of the groups. Sales is going to find the mean sales for each group, and price is going to find the mean price for each group. So if we run this, and then if we come up here, we have called this sales data. And so I could look at sales data here. And looking here, what we see is for each of the different advertising groups that we created. Remember, so here's all the different levels of advertising. So for example, for advertising level 5, which was a budget of $5,000, there were 19 locations in that category. Here is the average sale, and here is the average price. All right. We could use a filter to remove low count car seats, and so what I mean by that is we're going to remove the groups that have 10 or less in them using the filter that we saw last time. So now if I look at sales data 2, notice instead of 28 groups, that's knocked that down to 13. So here's my 13 different groups, all of which had 10 or more in them. And then finally I could use a ggplot to look at this. So here what we've got along our x-axis is price, number of sales along the y, and then the size of the points indicates how many were in each group. Now the legend here isn't terribly important. We're doing this more just for illustration, but that's what's going on in this plot. So notice in this code above, we had to create several different data sets to help us out, but none of these data sets we actually cared about in the code. Oops. I'm going to remove that in yours. That's not actually, that was from your textbook there, from their example, so we don't actually need that. So, but in the code above, we had to create intermediate data sets that we don't actually need. And so the pipe operator gives us a better way to do this. So notice if I run this code right here, sales data 3, and then I'm going to go back up to my ggplot and just change that over to sales data 3. I get the exact same plot. So you can see here if I flip back and forth, it's the same one. That's why it doesn't look like there's a change, because it's exactly the same. So this line of code using the pipe operators takes the place of all of this code. And so let's talk through what this code is doing. So each of the pipe operators reads as a then. So what this is saying is it's saying start with the car seats data, then group by advertising, then summarize that data set and include the counts for each group, the mean sale price, and the mean price, and then I want you to filter so we only have groups with counts greater than 10. So that's how you would read this like a sentence, and so the pipe operator is always going to read like a then. So let's look at one more example here. We could use mutates and filters together. Alright, so let's say that we wanted to find the 3 worst members for each group, where in this time groups are going to be divided by urban and US. So again, we're going to start with the cars data set. Then we're going to group that data set by urban and US. Then we're going to filter. And so this filter looks a little different than what we've seen before, but what this is saying is I want you to take sales, write them in descending order, and then rank them. So I want the ranks for each group that are less than or equal to 3. So in other words, this is going to give me the 3 bottom sales for each of the groups. And then I want you to arrange it by US and urban. So let's run this. Notice we get our poor sales data set. So if we look at it now, notice if we look here at the urban and US, what we get is we've got urban no, US no, and we have the 3 lowest sales for that grouping. We have urban yes, US no, 3 lowest sales for that grouping, no, yes, 3 lowest sales, and so on. So this is a good way to group your data and find the lowest values that occur within each of the groups. We could also find the largest values in each of the groups. There's lots of different things we can do here and pull that information. So we're going to work a lot with pipes in lab this week to help you get used to how to write these and how to use these. And really you want to be able to do this because it's a nice condensed way to write your code, so you're not creating all of these extra data sets that we've been creating in all the practice problems. And then also in the scripts, we'd run out of names. We'd be looking at Starbucks 1, Starbucks 2, Starbucks 3. And by using the pipe operators, you can get rid of those unnecessary naming conventions. And that is going to end this video. So of course, as always, if you have any questions, please let me know.